Rational functions, page 4. We're back to the degree of the numerator being less than the degree of the denominator. I want to show you another way to think about what's happening as x goes to infinity. Should be a little bit of a parenthesis there. You might want to fill in on your notes. Another way to look at it is just to look at the leading terms of top and bottom, which gets us x squared over 2x to the fourth. The terms with the highest powers are the one that are going to overpower the function as x goes off towards positive or negative infinity. And since that reduces to 1 over 2x squared, and if I plug in a infinitely large positive or negative number, when I square it, it's going to be positive times the 2, it's positive, in the denominator it stays positive. Anyway, we got a positive large number in the bottom, so I know that the whole thing, since it's in the bottom, is going to go to 0 as x goes to infinity. This goes to 0 as x goes to plus or minus infinity. That causes the x-axis, or the equation y equals 0, to be our horizontal asymptote. Our x-intercept is going to come from when the numerator is 0. That's going to be at 2, so I could just say 2, 0. Our vertical asymptotes are going to come from when the denominators are 0, as long as they don't cancel, and they don't in this case. So that's going to be at x equals 1/2 and x equals -1. Our y-intercept is going to come from plugging 0 in for x everywhere, which is going to leave us the constant 4 on top and -1 on bottom, or just -4. So we end up with 0, -4. And this type of thinking I was doing before was also to let you know that since 1 over 2x squared is going to be positive for any large values of x, positive or negative values, that if I use that for my sign chart, I know that the right region is going to be positive. Let's include our zeros and from both the top and bottom. So that's the 1/2, the -1, and the 2. Those were the zeros. The x squared plus 1 is always positive, so we don't need to worry about it. So I've got -1. I've got 1/2. Oops, that's positive 1/2. And I've got 2. And we've already determined that it has to be positive to the right because 1 over 2x squared is going to be positive when I plug in large numbers. This time, as I cross my 0, I'm not going to change the sign on the first one because the multiplicity of the factor that 2 came from is 2. It's an even number, x minus 2 squared. So an even number, it's not going to change sign. It'll stay positive. The multiplicity of my other factors are both 1, so from there the sign will alternate. Okay, now we have all the information we need to make a graph. It might not seem like as much, but it is enough. So I pick a scale, and I'll call that 1, 2, and then I'll do the same thing on the other side, try to make it about the same, but these are just rough graphs, excuse me. They might be a little off, but I got a vertical asymptote at 1/2, a vertical asymptote at -1, and I cross my x-axis at 2 and my y-axis at -4. And from my sign chart, I know I'm positive to the right of 2. This time, since the x-axis and the x is the horizontal asymptote, I don't have to worry about being above or below them both. They're one and the same. So I know I'm positive on both sides of 2. That means I got to approach from the top. My vertical asymptote's going to come up here, come down, hit the graph, the x-axis at 2, but stay positive. Instead of going through, I'm bouncing off the graph. And then I got to come back and approach. Now the hump would not be that pronounced in real life drawn to scale, but I still want you to illustrate the hump to let me know that you know this thing bounces off, goes away from the x-axis, and then comes back. But in reality, it all probably happens really close to the 2. Okay, in the next region, we know that we're negative. And we also know we don't have an x-intercept there because we already figured out our x-intercept. So that means I'm stuck inside these 2 vertical asymptotes, but I cross at the point that I decided would represent -4. And in the region after that, between -1 off to negative infinity, everything's positive. There's no interesting points. It doesn't cross. So there's no choice but just to make a simple graph approaching both asymptotes. Keep your graphs simple everywhere that nothing interesting is going on, and you'll get a good graph. And that's it.